Okay, so today's learning goal, we are going to be able to recognize and create equivalent fractions. And I know a lot of people have some hang-ups and baggage with fractions, but we're going to try and distill it down and make it as easy as possible, and hopefully we'll be able to help you with any issues you may have. So equivalent fractions, the root word in equivalent is equal. And this is a underlying theme in mathematics, that we have expressions that can have different appearances. This is a big idea, different appearances but the same value. And that's huge in math. Okay, so examples can be in fractions, equations, square roots, exponents, etc. So something as simple as 10 equals 8 plus 2. Okay, so you can see both sides. They both have a value of 10 on each side, but they have different appearances. Okay, so when we talk about equivalent fractions, we're going to be talking about things like this. Okay, 1 out of 2, or 1/2, is the same as 5 out of 10, or 5/10. Okay, though they have the same value even though they have different appearances. So we're going to go through a couple of different models. You do not have to use models. I use them just to communicate and try and lay the groundwork for deeper understanding. So we have fraction strips, which you can make at home with paper if you wanted. We have a grid model, which you can draw on fraction circles, which I don't use a lot of, but I'll show you them anyways. Okay. So the following are equivalent fractions for 1/2. So I have a model of a fraction strip. This is 1/2. You can see, whoops, let's do that again. Here's a 1, and you can see that it's pretty close. There we are. So 2 halves make up 1 whole. So we're only dealing with half here. So if I want something equivalent to it, I might be able to stack 2 quarters. That would be one option. I could stack 3/6. Okay, if I can actually get them to stack in the right location. And then I could do 4/8. Okay, and I'm trying to go quickly here so they're not stacking super well, but you're going to get the idea. Okay, and I'm not going to do the 16ths because that's going to take a while to move it all around. Okay, so if I was to look at the numbers here, what we would have 1/2, we would have 2 quarters, 3/6, 4/8, and if I did 16ths, you could probably make the jump to 8/16 without too much issue. Okay, so those are all equivalent fractions. You can physically see they're all the same height, even though the size of the pieces are a little different, but they all take up the same height. Okay, so if we want to have an equivalent fraction for 3/4, okay, so I need to stack something up here. You can try different things and see what happens. If I try thirds, you'll notice, okay, that's too short, even if I get them touching. If I add a third one, that's too tall, so thirds aren't going to work very well. Okay, I could do 8ths and see what comes up with 8ths. I could try a bunch of these different shapes and see how they fit. What we want to eventually get to at the end of the day, though, is that we're going to have a faster way of doing this without drawing or moving a lot of these things around. But this is a good place to start for understanding. So if I have 3/4, if I count up these 1, 2, 3, 4, 5, 6, 8ths would be equivalent, and you can see that because they have the same height. Okay, so if we have something like a fraction circle, this is what a fraction circle looks like. So that would be a whole. There's 2 halves. Underneath the halves you would find 4/4. Underneath that we can go back to a whole again. Okay, so we can use circles, we can do lots of different things. So shade in the following fraction amounts. So these ones will help try and connect a few ideas together here. So let's do blue here. So this one here is 7/28. So there are 28 squares on this little grid here. There's 4 rows of 7. So if I want to color in 7/28, I would color in the top row. Okay, and that would be 7/28. If I come over here, 6/14. This means out of every 14 squares, little squares, I have to color in 6 of them. So if each row is 7, there's 6/14. Okay, and I'll change colors. Here's the second group of 6/14. Down here, 3/7. So this says out of every 7 you have to color 3. So there's 3 out of that top 7, 3 out of the next group of 7, 3 out of the next group of 7, and 3 out of the last group of 7. And lastly, 1/4. This says out of every 4 squares you have to color 1. I'm going to use these as columns. I'm going to go this way. So that's 1 out of 4, 1 out of 4, 1 out of 4, 1 out of 4, 1 out of 4. Okay, now you might notice something. You might say, hey, look, those two have the same picture. And you'd be absolutely right, because 7/28 is equal to 1/4. Those are equivalent fractions, and we can see it when we look at the pictures. Okay, so if you want to pause it and take a little look at these ones, we're going to fill them in a minute. So shade in the following fraction amounts. Each one of these rectangles has 15 little squares or rectangles in them. So I'm just going to switch to a highlighter to make it a little easier to see. So if I do 5/15, there's 5/15. Okay, if I do 12/15, so out of the 15 I have to shade 12. So there's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and there's 12 shaded. Okay, 4/5. So this says out of every 5 squares or rectangles, you have to shade 4 of them. So there's 4 out of the top 5, there's 4 out of the second group of 5, and there's 4 out of the last group of 5. Now again, you might notice something. You might say, hey, look, these two are the same. And you would be correct. 4/5 is the same as 12/15. Okay, and then with the last one, 1/3. So out of every group of 3, you shade 1. So I'm going to do this as columns. So there's 1 out of 3, 1 out of 3. I'm going up and down the page here. So I have 1 out of 3. And now again, you might notice something. You might say, hey, look, those are the same. Okay, and 5/15 is equivalent to 1/3. Okay, so you might be starting to get a bit of a plan or a pattern here. I'll gladly show you that in a moment, because there is a quick way of making equivalent fractions. So let's just look at these one more time here. So what fraction amounts do the following represent? So if you look at this one here, there's 5 shaded in out of 15. Okay, and that's looking at the whole package. But if you just looked this way and you looked at every group of 3, you would see that 1 out of every 3 is shaded in. Okay, over here we would have 6 out of 15, or if you looked this way, you could see that out of every 5, 2 are shaded. Okay, down here on the third one, you might count that as 3 out of 15, or if you looked out of every row of 5, 1 out of every group of 5 is shaded. Okay, and now lastly we would have 10 out of 15 shaded, or if you looked this direction, you could see 2 out of every group of 3 is shaded. And all of these are equivalent fractions. So what we want to learn is how do we move between those two different values. Okay, so we'll just do a little background work. So first question, does multiplying by 1 change the value of a number? So if you went 2 times 1, that's the same as 2. If you went 5 times 1, that's the same as 5. So when you multiply by a 1, it doesn't change the magnitude, okay, of the original value. So now, can 1 be represented in more than one way? So if you had 2 divided by 2, that's equal to 1. If you have 5 divided by 5, that's equal to 1. Okay, and what we're going to do is we're going to take these two ideas together, and we're going to come up with our shortcut. Okay, so what I want you to see right here, this is 1/2, and this value right here is a 1. Okay, and we'll do a little bit more work with multiplying fractions in the near future, but for now we're just going to take this as the way it works. So if I multiply it across the top here and across the bottom, so this would become 2/4. Well, my original fraction was 1/2. If I multiply by 2 divided by 2, that's 1. So I have created a new fraction, 2/4, that has a different appearance but the same magnitude. Okay, so these two things have the same magnitude or value, but they don't appear the same. Therefore, they are equivalent fractions. Okay, so if you look down here, here's 1/2 times 3/3. Again, this represents 1. So if you multiply the top numbers and then you multiply the bottom numbers, you get 3/6. Well, 3/6 is the same as 1/2. Okay, in terms of their value. Their appearance is different, but their value is the same. So if you want to pause it here, okay, and create two of your own creation, you can create two more equivalent fractions pretty quickly. Okay, so I'm going to do the first one. I'm going to do a 20. Yep, you can choose whatever numbers you want. As long as you have the same number on the top and bottom, this will create a new equivalent fraction. So if I multiply across the top, I get 20/40ths, and that will work. I could put a 100 in here. Okay, if I multiply across the top, that becomes 100. If I multiply across the bottom, that's 200. So all of these ones here, 100 out of 200, 20 out of 40, 3/6, 2/4, they're all the same as 1/2. Okay, so it's a pretty quick way to creating an equivalent fraction. So let's try it with something other than a half. So I want to find 3 equivalent fractions for 3/4. Again, if you want to pause it and try it on your own, now's a great time. So I'm going to take 3/4 and I'm going to times the top and bottom by 2, and I will create a new equivalent fraction of 6/8. I can take 3/4, I could times the top and bottom by the same amount of 5, and I would create 15/20. And then I could take 3/4 and I could times the top and bottom by 1,000, and I would have 3,004 thousandths. That's tricky to say. And all of these right here, here, and here are all equivalent to 3/4. Okay, so equivalent fractions can be created by multiplying up to create larger values. But if we're looking for something called lowest terms, we want to actually get the fractions to be smaller. So we can create equivalent fractions that are smaller by dividing down. Okay, so we can take a large numbers and divide the top and bottom by the same amount, and we can shrink them. So if we have something like 12/20ths, if you divide top and bottom by 2, you get 6/10. Okay, now that is an equivalent fraction that's lower, it's smaller, but we want to try and go as low as we can with these, so I'm going to divide top and bottom by 2 again. And I create 3/5. Now, because these numbers 3 and 5 don't have any number that's shared between them, I can't keep dividing anymore, so this is my lowest term. Now, I don't have to do this in 2 steps. I could have seen that 12 and 20 both shared the number 4. And if I had have seen that, I could have divided both by 4 and gone straight to the lowest term answer. Okay, so let's look at something called mixed and improper fractions. We're almost done here. A mixed fraction has a whole number in front of the fraction. So that over here, this is a mixed number. An improper fraction has a numerator that is larger than the denominator. So numerator is a fancy word for top. Denominator is a fancy word for bottom numbers. Okay, so this is an improper fraction, 11/4. But a mixed is 2 and 3/4. Now what we learn is that we can move between these two things. So if you look here, 2 and 3/4, if we count, there's one whole unit. There's a second whole unit. Okay, and now I only have 3 out of the last one, 3 out of the 4/4. So this is 3/4. And if you add all those up, you end up with 2 and 3/4. Or if you counted the number of quarters, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 quarters. So you can see these two things are the same. Okay, they have different appearances, but they have the same value. Okay, so sometimes a diagram can really help with these. I'll show you how to move between mixed and improper. Again, just try the diagram once or twice. It'll make a huge difference. So here's 3 1/4. So there's 3 whole units. And they all have quarters in them. And then the last one, and we're going to shade this in so we can see. These guys are full. This guy's full. This one's full. And just one of these is full. Okay, so that picture goes with 3 1/4. If you count up the number of quarters, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and one more. Okay, and what you'll see here is this is 3 whole units that each carry a 4 plus one more, and we get a total of 13 quarters. Okay, and there's going to be a nice little shortcut here. You'll notice this 3 times 4. We're going to do a little pattern like this to come up with this improper fraction. If we do from improper to mixed, you could do this a couple of ways. 5/2, you can actually do the division. How many 2's fit into a 5? Okay, well, 2 groups of 2 fit into a 5. So here's okay, and if we color those in, oops, I should have made that blue. So here's 1, 2, 3, 4, 5 halves. Okay, and 5 halves build 2 whole units and 1/2 of the last unit. So the mixed value would be 2 1/2. Okay, and if you did the division over here, this is another way of looking at this. If you did the division and you subtracted 4, which is 2 groups of 2, you would have 1 left over. So that whole number right there, that 2, is this guy right here. Okay, so I'm really hungry and I have been offered the following proportions of cake, but I don't know which one to take. So should I take 2/5, 1/2, or 11/20? Okay, and this is where equivalent fractions come in really handy. If we can get them all to have the same denominators, the same base number, then it allows me to compare how many of each type of those pieces of cake I have. So I'm going to look at these and I can get all of them to a base 20. So if I have 2/5 and I times top and bottom by 4, I have 8/20. If I have 1/2 and I multiply top and bottom by 10, I end up with 10/20. And the last one is 11/20. So when I look, they all have the same size pieces. Okay, but now I'm looking at how many of them do I have. Well, if you look at this, this one has 8, 10, and 11. So the 11/20 is the most amount of cake, slightly larger than 1/2. So we know it's bigger than this one, and it's bigger than this one. Okay. So Mr. Furok comes along and offers me 14/25 of a cake. Oh no, what should I do? Okay, so now 14/25, this means I need to get another denominator that they can all share. Okay, so if your multiplication facts are kind of good, you can kind of jump through this really quickly. The number that we're going to look for is mostly going to be predicted by those two together. Okay, so 100 would be the smallest number that they share. So we're going to try and get all of our denominators to 100. So this guy I'm going to times top and bottom by 20. So this becomes 40/100ths. This becomes, you've times top and bottom by 50. This becomes 50/100ths. This one we're going to times top and bottom by 5, and this is going to be 55/100ths. Now if you look at this, this shouldn't be a big surprise. From the previous question we know that this one is bigger, so 55 is bigger than 50, which is bigger than 40. This last piece though is the one we have to spend a little time on. I'm going to times this guy by 4 on top and bottom, and that's going to give me 4056 100ths. So if you compare these now, is 14/25 just slightly larger than 11/20? And the answer is yes, this is the largest piece of cake. Okay, that was a long lesson. Thank you for tuning in. You have a task for equivalent fractions. Good luck.